Hello, my name is Rob Sandstrom. Today we're going to focus on something different than we did the last two Laguna videos. In the last two videos we focused on sign making and the ability to take VCarve Pro and use that to make your signs. Today we're going to focus on a cribbage board, particularly the ease of producing a cribbage board any size you would like to produce it in any shape, primarily supported by the changes instituted in VCarve Pro version 11. Prior to version 11, when you had to resize holes or text in VCarve, it was a long, hard process and you had a lot of work to do. Now, with version 11, you're allowed to resize individual objects within a group in a matter of a few keystrokes. So today we'll focus on the cribbage board that we designed in VCarve Pro, on how to cut it and how to use the tools to get the results that you want.
The purpose of this video is to demonstrate how to make your own unique cribbage board in whichever design you would like, using a template and taking advantage of the recent changes in Vectric 11 to make that process easy and straightforward. To start the process, we'll create a new project as we always do. So we would go to the Create New Project menu. We now have a project. It comes to the opening window. This will be a single-sided project. Let's go ahead and select 10 inches wide by 30 inches long and 1.25 inches thick at this time. The templates that are being provided will be able to fit on this, and then of course we're going to resize as appropriate. So there are a number of templates available to you, including one that will be supplied with this video. Let me show you some of the templates that are already available. Go to the clip art library in the Vectric software. Click on clip art and you see 2D game layouts. Any one of these templates for games can be used. We're talking about a cribbage board, so we could pull over an oval if we wanted to. Or we could pull over your standard cribbage board if we wanted to. Or we could pull over this cribbage board round. All of them are available already, ready to put into your project and size as necessary. We will be providing our own vector for this video, and it's available to you from Laguna. To get to our cribbage board, we're going to use the standard method of importing a set of vectors. At this time, we're importing a vector that you can use to manipulate and make your own boards with. The first thing we'll do is center this on this board by using the alignment function. And we now have the cribbage board template. What you'll see different between this template and the ones provided by Vectric are, let me open that up for you real quickly, is that the ones provided by Vectric, as you see, do not have any of the scoring, the grid lines, the start, the finish. As you can see, the vector that we've provided provides that information. You can turn it on or turn it off as desired by turning on and off the layers. And there's all kinds of ways to apply this template, and it can be modified very easily and moved and arranged to make various types of cribbage boards. Here are examples of a few I've made. So this is a very small cribbage board with 1/8 inch pegs, typical. This is a larger board that a friend of mine asked me to make him out of a large piece of curly maple. This is one I made for the fire department. I do a lot of volunteer work for fire departments. They really like to play cribbage and they like their boards big. So let's get started into manipulating this cribbage board. So the first thing we want to do is recognize there are two sizes of pegs used in a cribbage board. The typical small size peg is a 1/8 inch peg, and it's typically anywhere between a 1/2 inch to a little longer deep. The other peg, which people like, is a 3/16 inch peg, which is a bigger peg and used for bigger cribbage boards, and it's close to an inch deep, about 0.95 inches or so if you want to bottom it out at the shaft. So we need to check each template we get to see what size of hole or what size of peg the holes are supporting. The way to do that is to first pick a hole. In this case, we'll pick that hole, and we're going to go to the Transform Objects tool. We're going to check the size of that hole, and it says it's 0.1875 by 0.1875. That tells us that this cribbage board is built for larger holes, which are 3/16 inch pegs. So if we want to modify this board, let's say something simple as making the board fit this whole big piece of timber. Let's say we were putting it on a big slab or something else. We'd want to make this fit that slab, or if we wanted to shrink it a little bit, we might want to shrink it and add a bigger logo, say, up at the top. So the way we would do that is, first we want to group the entire board, and the reason we want to do that is so that everything moves in unison together. Depending on your computer speed and other factors, it could take a few seconds for this to occur. Okay, it's grouped. You can tell, you saw the little blink of the screen, and the whole holes and everything went solid, so we know that that's grouped. Now we can resize this board a couple different ways. One would be to hit the shift key and grab the corner, and that will move everything together. That's one way. And you can kind of play with it a little bit, as much as you want. Sometimes it gets a little touchy. The way I typically like to do it is, if I know the size of hold downs or other factors and how big I want to make this board, is I simply take the grouped area, I go to the resize tool, and I put in exactly what size I want. So in this case, let's say I wanted the limiting factor to be the Y direction. So I'm going to go ahead and say I want to go ahead and make that 27 inches. Leave that link XY, hit apply, and we can see that that now fits onto the cribbage board very nicely. So one might think, well, we've got the cribbage board resized, we're ready to go to the toolpath and start cutting. But the reality is, when we enlarge this, we change the size of not only the text but all of the holes. So now the 3/16 inch pegs will not fit in to the holes properly. So first we must ungroup what we grouped. You can tell it's ungrouped because it is now all shifted to the dotted lines. If we click on a hole, what we'll see right now, if we look at the sizing, is that those holes have gone from 0.1875 to 0.2337, which means our pegs will be floating in the holes and be too big. We want them to fit in there nice and snugly. So we need to change that. This is where the version 11 change in Vectric will help streamline this process. So let's show how we would do that. First of all, we're going to turn off the grid and the text. I have those on separate layers. Then we're going to go ahead and select all of the holes. We're going to go to the resizing tool. You'll notice there's a scale selection. So we scale selection, that will scale everything in here. That's how we actually made the grid and the template bigger earlier. We're not going to do that this time. So this time we want to scale items individually. So we'll click on scale items individually, and now what it will do is approach every item that's highlighted as an individual item. Want to go with inches because we want each of those holes to be 0.1875. You'll see I hit two dots there. We want to link the X and Y together. We hit apply, and we notice that the holes just changed size. We're going to go ahead and turn back on the grid and the text, and we now see, if we check each hole, that each hole is now the right size for the peg. If we were using 1/8 inch pegs, we would do the same thing, but instead of putting in 0.1875 for each of these, we would put in 0.125. We'll go ahead and group these to make them easier to deal with as we set up tool paths, etc. Alright, so now let's set up the tool paths. First tool path we'll set up, which will be the longest of the tool paths, will be to drill the holes. The way we like to do that is to come up to the drill tool path, the third one in. This has been set up before for these kind of holes, so I'll just walk through the settings real quickly. The pegs are about 0.95 inches deep. The material that we're using for this demonstration is 1.25 inches deep. The tool is 3/16 inch core drill bit. Those are bits that are built especially for CNCs to do this kind of drilling. We're going to use a peck drilling method, which means we're going to come down and drill each of the individual holes, and we're going to retract above the cutting start of the depth. That allows you to pull material out. So from each peck, we'll now go down and then come out and go above, and then we'll go down and come out and go above. So we're retracting above the cutting start depth. We've got a peck depth of 0.5 inches. That's determined by our path depth for our tool that we have. I want to dwell at the bottom of each drill pass to ensure that I'm getting a nice clean bottom. Once we have all of that selected, we're going to go ahead and calculate this tool, and I'll just go ahead and put holes for my tool path. Let's preview. And that's what we have. Those are all the holes. So the next tool path that we want to set up will be our grid. So the grid, you could do that a number of ways. The easiest way that I found to do that in this cribbage board is to go ahead and set up a profile tool path. I'll turn off the holes and leave the grid in place to make it easier to select. I'm going to go to a profile tool path. I'm going to select the grid, and I'm going to use a V bit, and I found that about 0.05, 0.06. You'll have to experiment with that. That's a little over 2 millimeters deep. I'll select a V bit, and you're going to see we're going to put that right on the profile. So I'll select a 90-degree V bit toolpath, and we're going to go ahead and put the profile cut right on the grid line itself. We don't need a separate last pass. We're not cutting through, so we don't need to add tabs. We don't need to ramp this bit in. So I'm going to go ahead and put text here. Hit calculate. And let's preview that toolpath. All right, now we have a nice toolpath. We wanted to add color to it. We can go ahead and put the grid lines as black. And the final toolpath we need to put in place for the actual cribbage board will be the text. The toolpath we want to use for the text will be your typical VCarve toolpath. We'll go ahead and highlight all of the text. I'm going to select another V-bit. I like that 90-degree V-bit. Means we don't have to make another tool change. So this is the one that we selected before. Select. We're not going to put a flat depth at this time. We don't need a clearance tool. And we'll call this text. Oh, I see I made a mistake before. We should have called the previous one. Let's rename that. You guys already probably caught that, grid. We'll go ahead and preview the text. Let's paint that black also. And we can see that that text doesn't look like it's going in very deep. And if we go over and we hover over the text slightly, 0.0079 or so, we see that we're not getting very deep. So if we do any sanding, we could sand that text right off. So we want to be a little deeper. So the easiest way to do that and adjust that is to edit that toolpath. And we actually start, let's say start at 0.02. And since we were 0.079, let's take a look. Calculate. We'll go ahead and preview that visible toolpath again. You can see it got deeper. And now you can see that the depth of these letters are more like 0.01, 63, etc. 0.01, 0.02. And that should allow enough area for sanding. If you want them deeper, you can make them that way. Now that we have the toolpath set up and we have the depths of cut looking good, we're ready to go ahead and go to the CNC and cut this board. The next step would be to save all these toolpaths to a USB drive with proper names. So let's head out to the Laguna and cut this board.
Okay, we've already done a couple things in setting up to carve this material. We've fastened it down. We've made sure that the machine was turned on and homed. Remember, we home the machine every time when we start this. We're at the point now where we're actually going to install the bit and get ready to cut this thing. So that means we have to install the bit, and then we'll have to home it at the XYZ, or set the XY 0 axis. Once again, we're looking for the little line here that tells us that we've got the tool deep enough. I hold it with my thumb, hold the bit in. And now we're going to set the XY 0 axis. I'm looking right down at the center line of this V-bit. We are going 0.5 millimeters for each jog that I do. That looks good. So now what we'll do is we'll press the XY 0. That tells us we've got that coordinate. zeroed out. Let's move to the board where we'll be carving. And we'll go ahead and zero the Z-axis. Recall that we always want to check this plug to make sure that it's in properly. Move it down close to the Z, and then hit Menu, On button together, and it will cause it to zero out. So now we set the Z0, and we're ready to select the program to cut. After, of course, we put on the safety glasses and turn on the dust collector. One interesting thing I thought might be a nice pro tip is if you want to know the cutting time that the program thinks it's supposed to run versus what was just put into VCarve Pro and compare which one's more accurate. This runs off the G code, so it would probably be the more accurate of the two cutting times estimated. That can be done. Here's a little pro tip. All you have to do is have your USB port, plugged into the port, go to Menu, go down to using the 5 key or the down key to the operate file, hit OK. Then you want to go down with the 5 key again, to check pro time. Hit OK. You're on your U disk, so you're going to go ahead and hit OK. And you can see you've got your programs that you're running, that you're going to run. So the first one we're going to run is 45701, which is our V bit. So if we check that, you'll see that it says this is supposed to cut 8 minutes based on the fact that we're reading the G code, which is the more accurate way to do. Hit stop cancel, hit check pro time again, hit U disk again, and then we'll go down to the drill path, which is the longer path, hit OK, and the machine says we should be able to cut that in 35 minutes. Little extra pro tip for you. All right, let's go ahead and turn on the dust collector and get ready to start cutting. Hit the run pause, U-disc. First one we're going to run is the 45701 drill path. Hit OK. All right, we finished with the V carving. Looks pretty nice and clean. Now we're going to switch over to the next bit for this carve, which is the hole drilling. We're using this specialized core drilling bit for CNCs, and that will make the peck drilling process a little better. You can do this either with a core drill bit, which is what this is, or you could use an end mill if you wanted to. I prefer using the core drill bit. It has less heat and less friction than using a regular end mill. Once again, like to clamp them. Holding the bit so it doesn't drop and hit anything. I'm missing my little styrofoam today. We're going to zero the bit. By hitting menu on at the same time. Now we've got the bit zeroed in the Z axis. We already zeroed it in the XY axis. So one other thing we have to do with this bit is we need to take the RPM down to about 10,000, then we'll monitor from there. But that's the recommended drilling speed for this type of bit. And that's something we haven't shown before, but we need to do. To do that, you need to take the VFD controller down here, and there's an up button and a down button, and you need to move that to the equivalent of 10,000 RPM, which is 166.67 or 167 in that area. We know that by taking 10,000 and dividing it by 60. That's how you decide what the 10,000 RPM is. 10,000 divided by 60. So by pressing the button, we're now at 167. I just rounded it up. So the speed should be right. We'll watch it and see how it cuts. And if we need to adjust it up or down, we will. So now we're at the point where we're getting ready to cut. Turn on the vacuum, put on my safety glasses, and start the machine. Using the drill path, hit OK, hit OK. All right, we just finished the cut. Looks pretty good. One of the things I wanted to point out is when we estimated through the calculator there how long it would take for this drill path to complete, it estimated 35 minutes. You can see I hit stop when we started, start when we started and stop when we stopped, and you can see the time right there, almost 35 minutes exactly. So it's a pretty close calculation if you want to estimate your tool path time. Maybe go have a soda or a cup of coffee or something while you're waiting for your machine and just keeping an eye on it. You may recall in the video on designing this cribbage board, we said that there are two typical sizes of holes for pegs. One is 3/16 inch, one is 1/8 inch. I typically make the bigger ones because the people I make these for are typically firemen and other people that tend to like their boards bigger and bigger pegs. And so this is the size of peg that I use. And you can see how it fits in and how it did a nice job and fits real nice in the cribbage board. As I said, it did a nice, pretty clean cut, and pretty happy with the results. I hope you found this information useful. And if you like this video and what you saw, please remember to like, share, comment, and subscribe. And in the comments section, if there's other information you'd be interested in seeing in these videos, please share that with us, and we will consider those for future videos.